Welcome to today's movie. In today's movie, we're going to look at the non-parametric Wilcoxon paired samples test or assigned rank test. And in this particular movie, we're going to use Excel to solve a particular problem. And if we go to Excel, you'll see that we're looking at example 8.6 from the book. And in this particular case, we are told that a study is made to determine whether there's a difference between husbands and wives' attitudes towards online marketing advertisements. A questionnaire measuring this was given to 24 couples with the results summarised in the table that you can see on the screen in cell C5 to D28. So the question is there a significant difference with the couple's attitude to the online advertisements at a 5% level of significance? So what we have here is I put in column B the ID 1, 2 to number 24 for the 24th couple. The wife's results for each pairing is in column C. The husband's results are in column D. So you can see for ID 1, the wife's score was 15, the husband's score was 17, etc. So what we want to do is we want to be able to, and you can see there's the Excel solution, which we're going to talk about shortly, and there's the step structure. So step 1 is to state the hypothesis test, and the hypothesis test says that the null hypothesis is that there's no difference in attitudes to the online advert, and the alternative hypothesis that we're going to measure is the difference does exist. So because it says difference, we have a two-tailed test. So, and then we set up these, as you can see, the series of steps. Step 2, which is select the test. Step 3 is select the level of significance. And step 4 is extract the relevant statistics. So now, remember, this is the Wilcoxon test for paired samples. You can use it on one sample if one of these columns was a fixed number, or you can do it on two samples. So it's equivalent to a one sample t-test where you fix one of the values, or a two sample dependent t-test. So if our data, we have a problem with the t-test in terms of the data is, for example, not normally distributed but heavily skewed, or the data is ordinal like it is here, then we would use a non-parametric version of the one sample t-test or the two sample independent t-test, and that would be the Wilcoxon test for paired samples. So what we do first is, as you can see, we've got a series of columns. So in the first column E, we want to calculate the difference between the wife's score and the husband's score. So we do that by C5 minus D5, and then copy the formulas down to give us these numbers. Then what we do in column F is we put in a if statement, because we want to know what the sign of that difference is. So we can see here the sign of that difference is negative, the sign of that difference is negative. This one here, you can see the scores are exactly the same, so difference of 0. So when we come to the actual calculation procedure, those values will be eliminated, removed. So you can see if you look here, look, that score 16 minus 13 is 3, so it's positive. So, okay, so what we can do is we can use this if statement and then copy the if statement down. So as you can see there, it's if, open bracket, C5 less than D5, comma, quote, minus quote, comma, if, open bracket, C5 minus D5, comma, quote, positive quote, comma, or quote, quote, close bracket, close bracket. That quote, quote is where you've got equality. So it doesn't put anything there. As you can see, it's just blank. Okay. And then what we do then is we then calculate the magnitude of the differences between the two using the if statement, open bracket, C5 minus D5 equal to 0, comma, quote, quote, comma, absolute value, open bracket, C5 to D5, close bracket twice, and then we can copy that formula down, just like we can copy that formula down there, as you can see on the screen. And then what we do then is we rank the differences. So we want to rank these differences here. Okay, and we can use an if statement. So if open bracket h5 equal quote comma rank dot average, because it's an average rank we're after from h5 to h28 and then 1, and then copy that formula down to get all the ranks. Once we've done that, we want another column which gives us the positive ranks and another column which gives us the negative ranks. So we want to identify the positive rank values and the negative rank values. So again, we can use this formula, this if formula, if open bracket f5 equals quote positive quote comma j5 comma quote etc. And if you copy that formula down, you'll see that we have a positive rank there, which is 9.5. So we look here. So if we scroll across, there's 9.5 there. Scroll all the way across, there's a positive, and its rank difference is 9.5. So you can, and then if you come back across, you see we do exactly the same for negative using this other if statement. So equal if open bracket f5 equals quote negative quote comma j5 comma quote close bracket, and you can see it'll then pick up the negative ranks. Okay, then once we've done that, then we are in the position. Now remember, with Excel, it's a complicated procedure to do the Wilcoxon signed rank test. SPSS is a lot easier, as you'll see in another movie. Okay, so what we want to do first is we want to calculate the median difference, W minus H. So that is median open bracket E5 to E28 close bracket. So it's this here, E5, there we are, the median of those scores. And if you do that, 1 second, it comes out to be minus 1.5. So the median difference suggests that the woman's score is less than the husband's scores, okay, across the sample of data. So we know we're going to do a Wilcoxon signed rank test. We're going to choose a level of significance as 5% or 0.05. Then we extract the relevant statistics. So we want the number of women, so we can count them. So we count C5 to C28 to give us 24. The number of men is count D5 to D28 is 24, it should be. The mean W score, the mean women's score, is average C5 to C28, which is 10.958, 3 to 4 decimal places. The mean husband score is the average D5 to D28, which gives us 13.7083 to 4 decimal places. Then we can calculate the standard deviations. Now remember, we have a sample, so we have to use stdev.s. So the woman's standard deviation is sample standard deviation based upon that sample data is 4.0698. And the husband's standard deviation, sample standard deviation, is 5.13707, etc. Then we calculate the number of paired ranks. Now we have 24 paired ranks. We know that because we have 24 paired ranks. So we know that's true. We also know, if we look here, okay, we also know that we have 7 positive ranks. So if you count how many positive ranks, 1, 2, 3, 4, 5, 6, 7. So it should be 7. So we count L5 to L28. The number of negative ranks, if you count those up, you should have 15 in total. So we're using count N5 to N28. The number of ties is where the difference was 0. So we count if H5 to H28, comma, quote, close bracket. So it's, and then it'll pick up where we add 0. So we look here, we go to H, there we are. So it'll pick that up and it'll pick that up. Okay, so we have 2 of them. Okay, so once we've done that, we can then now state what the corrected number of paired values is, which takes into account the total number, which is 24, subtract the number of ties, which is 22. Then we sum the ranks up for positive ranks to get 55. And then we use the Excel function sum L5 to L28. And then we do the same for the sum of the negative ranks, which is sum N5 to N28. The mean of the positive ranks can be calculated now, and the mean of the negative ranks can also be calculated using those 2 formulas. So the mean of the positive ranks is S32 divided by S28, and the mean of the negative ranks is S33 divided by S29. So the test statistic T that we're going to use is the minimum value between that and that, So it's 55. So that's our test statistic, our Wilcoxon test statistic T. Now we're going to use a normal approximation to answer our question. And we know that for the normal approximation, the population mean for the distribution T is given by that equation. The population standard deviation is given by that equation. And there's our Z equation, ZT. Okay, so if you substitute in, you find that mu is 126.5. Sigma, the population standard deviation, is 30.8. Z comes out to be minus 2.3. Now that's quite low. Okay, now you've got two choices. You can either calculate a two-tailed p-value, or you can calculate critical value. So what I've done here is I've calculated a one-tailed p-value using the Excel function norm.s.dist, and it comes out to be 0.01. And then we double that to get the two-tailed p-value, which is 0.02. Then remember, our test is, if we look here, it's a two-tailed test. So all we have to do is compare the significance level of 5%, 0.05, with our two-tailed p-value, which is 0.02. Our two-tailed p-value is less than 0.05, so we reject the null hypothesis and we have to accept the alternative hypothesis. And that tells us we have a significant difference between the women's and the men's scores, etc. Now you could do a lower and upper Z critical value if you so wish. So 5% significance is 95% confidence. Therefore, that would be plus minus 1.96. And you can see our value is less than minus 1.96. So we reject the null, accept the alternative. You get exactly the same conclusion no matter which method you use. Please note, when we use SPSS, you'll find that it does not give you a critical Z value. It only gives you the P value. Okay, so that's the end of today's movie. Bye for now. In the next movie, we'll solve this problem using SPSS.